Who here is doing Java or .NET development today? Okay, the grand majority of you guys. I figured that would be the case. That's cool. Is anyone here doing any native dev for mobile at all? Any Android devs? Yeah, okay. Sweet. Okay, anybody doing any Objective-C? No one has bothered to do that yet. I don't blame you.
I'm okay with that.
Yeah.
That's cool. That was the point.
Yeah, that's what we were trying to do, and then ended up in careers doing it.
Yeah. So how about JavaScript on the client? Like in the
any
browser?
front-end devs?
Yeah.
Okay, so this isn't going to be completely freaky.
So you guys are aware of how terrible JavaScript is, I guess.
Sweet.
Yeah. It was like nods. Yeah.
Yeah. All right, so that gives us a good baseline to understand where you guys are coming from, and we want you to understand where we're coming from. And so lately we've been hearing the term first principles a lot, and these are just the first principles that Brock and I typically operate from. We're sharing this so that you don't think we're nuts, because a lot of the decisions we're going to make when we're building this stuff might seem completely crazy. We're going to use a lot of bleeding edge stuff. We're going to cut our fingers all over the place. It's going to be a ton of fun, but it's the decision-making process that we use when we're choosing technology and building tech.
Yeah.
Do you have anything to add to that? Or?
No, I don't think so. Like it's basically like we tend to like Brian says, like we favor web technology, and that's there's quite a few reasons, and we're going to get into that, and we're gonna explore why even though like it seems crazy to put JavaScript on the server and run that, like there's actually some significant advantages to doing it. And the application that we're going to build is going to highlight some of those advantages, but it really comes back to the principle of using like open web technology and the advantages that it has.
The thing I'd like to like stress too is that this isn't like a talk where we're telling you that this is the one true way to build software. This stuff changes all the time. It's a really rapidly moving space. It's probably the one interesting way to build software right now for us. But this isn't to discourage other tools, techniques, or whatever. Like we're not locked into what we're doing. And actually, this is a good segue into this slide. So early on in my programming career, I used to do MFC applications. Has anybody touched any of that stuff? It's like old Microsoft Combis. Yeah, it's horrible. So some of that's out in the wild still today. But I remember where I worked on this software project. We were like, we got to get out of here. This is bad business, man. And so our solution was to go to Swing. Yeah, right? And so this is why my hands are scarred from like tapping on old keyboards with like big CRT monitors in my face. A lot of tears streamed down. Yeah. So, and then I remember I was working for the same company. It was like a financial institution type thing. And we realized that Swing was really just getting unwieldy and unmanageable, slow. And somewhere along the line, we got sold on .NET as a solution to all this stuff. So we started porting over to .NET. And so now we've got 3 sort of proprietary quicksand traps that we're trying to like walk through to deploy stuff. When we moved over to .NET, initially it was believed that it would have been smart to build on top of the earliest versions of WPF. Remember that stuff? But that was... So all we really ended up doing at this company, and this lesson stuck with me, was that we just kept jumping from one proprietary trap to the next. And we're on this sort of treadmill of building clients that were deprecating every 2 to 3 years. But every 2 to 3 years, that same vendor was always happy to sell us a new stack, a new IDE, a new database, and a way better way. And this will be the last one. That whole bloody time, people are building websites. And even a lot of the crappy web clients that we had built, some of those, I think we were using Cold Fusion at the same company, are probably still running to this day. And the point isn't necessarily that any particular client technology is bad. I mean, I work for Adobe. Of course, client technology is good. Like, invest in Flash. No, that didn't work out very well either. So, the kind of one philosophical underpinning or first principle is we want to avoid these proprietary traps, just for our own longevity and mitigating business risk. That's about it. All I have to say about proprietary clients.
Yeah, I don't quite have the same experience. Like, so I I started with a LAMP stack, and I was kind of shown that open way like from the get-go. So I was a little bit fortunate to avoid some of this stuff, but like the thing that was nice about what was taught to me early on was just like the principles applied all the way through to even like the kind of technology we're using today. So like learning a LAMP stack and then like using something like Rails or Python or whatever, and then ending up into like the kind of stack that we're using now. A lot of the principles still apply, right? Where it's open, the development process is in the open, there's a lot of documentation, there's a lot of commentary and blog posts and people like building the ecosystem in an open way. And so yeah, like my experience is a little bit different, but
you won the same lesson though along the way.
Yeah, I think so.
When we arrived at the same company at Adobe, we were both completely on the same page that whatever we were building, we wanted it to have staying power. And we're developers, we're lazy. We didn't want to have to maintain stacks and have to rebuild stuff all the time.
Yeah.
Anyways, let's keep rolling. So that early company that I worked for also had fire drills all the time. We'd build stuff. I think we were on a regular deployment cadence of twice a year, which is at that time was considered completely normal. And of course, by deploying twice a year, as you arrived closer and closer to that date of that once a year or twice a year, it just turned into like 12-hour days, death marches. There's no way we ever hit that date that we were aiming for, and the management always knew we'd never hit that date because we had zero quality. A big part of quality is just turning deployment into a non-event. I mean, I think if you're at a GoToCon event, you already understand this. That continuous delivery is a really big key to delivering successful software. We read all over the place about how software fails all the time, but I think that most of that is just due to the fact that we treat delivery as a final publish step when it really should just be a part of your daily cadence. And there shouldn't be such thing as a fire drill, ever. And in order to ensure that, you have to have really good build tools and build chains set up at the very beginning of the project. And we're going to build you a build chain live today. Oh, yeah. So fragmentation is where stuff gets fun. I have a really awesome set of emoji cons down here that you'll be able to copy and paste and use with your friends. We hear about native versus web just about every day. Because of the nature of the Phonegap project, we get drawn into this ridiculous debate. And so, first of all, fragmentation happens. And it happens a lot in mobile, especially. In Android, I think there's something like a potential of thousands of devices that you could be testing on. And on the Phonegap team, we're probably testing on roughly about 30 at a time. This is a big problem. The web solved that problem really well. And people are trying to pit the web against native tech, which doesn't make a lot of sense if you start digging into how web technology itself works. So web browsers are, for the most part, written in C and C++. If you dig into their guts, you can check it out. And that's what your operating system's written in. If you check out your operating system, it's written in C and C++. If a browser doesn't do something, it's not because it can't. It's just because we haven't gotten around to implementing that part yet. And the Phonegap project is a really good example of this. So there is no native versus web. It's a troll's argument. It's a polarizing argument. It's a waste of time. The web is just learning from native platforms all the time and growing with it. It's really all I have to say about that one. I don't know if you have any further commentary about it.
Well, what do the emoticons represent?
Oh, I don't know. I just wanted to include them. Okay, so this is where stuff gets fun. And don't worry, we're not going to slide bomb you. There's not very many left at all, actually. So one of the things that Brock and I learned through trial and error and building stuff together, and especially in the open source world and getting a great deal of committership involved in the outside world and onboarding new users, was figuring out a tool chain and a replicable tool chain across the project that anybody could basically pick up the source, immediately run the tests, immediately run a build, and immediately do a deployment. And we're going to describe a tool chain for you. This is not the tool chain to end all tool chains. This is just a tool chain. There's plenty of ways to do this stuff. There's all kinds of alternatives in all your favorite languages.
Mm-hmm. So. Also, like, you can take pieces of what we're going to show you today. So like we break things up into a lot of pieces, and like if you take away one part of it that's like, oh, that's a nice way to execute an API, or that's a nice way to do this or that, that you can just take that one piece. So are we getting into the stack yet?
We're starting to get into the stack.
Okay.
I guess this is a little bit more philosophy, but
Okay.
I have like more old man tales. But one time when I was that young programmer and I was at a software company, I had to rename a couple thousand files. I can't remember why. It was like some test thing had changed or some kind of convention had changed in the company. And I started to go through painstakingly renaming them. I'm like, this is dumb. I should just write a script to do this. And our CTO at the time was looking at me doing it, and he's laughing. He's like, do you want me to like do that for you like right now? And I'm like, sure. Grabs my computer, pops open a terminal, throws in a string of commands that I could never read at the time, hits enter, and he's like, you're done. And I'm like, shit, how'd you do that? And he's like, okay, now do you want to learn about what computers are for? So his idea is that computers are really good at repetitive tasks, and people are really bad at it. And this is what they're meant for. And this is really about your tool chain at the end of the day. And it kind of inspired me to actually learn more about how to use my computer as a tool instead of trying to be a slave to it. To turn the tables and actually treat the computer like the tool that it is. So we have a bias for web technology, and we use it for all parts of our stack. It's not really up for debate anymore. The whole web thing seems to be working out fairly well. We're fairly certain those Google guys are onto something. That's Brock's old joke. And I totally stole it.
Yeah, cool.
I gave attribution. It's open for the most part. It's standardized for the most part. And the governance of the web is an interesting thing. But for the most part, you can count on it to stick around and be a tool chain that you can use in all aspects. So you might want to talk to us a little more. But Brock and I we're among those hipsters that have fallen in love with using Node. And we use it for just about everything. And so there's only a couple people in here, but we can talk more about Node and where it came from. Maybe actually you drive from here.
Yeah, sure. So Node.js, everyone here sounds like they've heard of it. It's Google's V8 on the server with non-blocking I/O. Why it's significant is like there's a couple of reasons. Well, there's the ubiquity of JavaScript, which is compelling for a few reasons, like code sharing and also like hiring people that know JavaScript can work on the server and the client.
Brock and I are both Canadians, so we'll say JavaScript, not JavaScript.
Yeah, we might say
just in case you're getting freaked out. Why are these guys saying that wrong?
Yeah, and so I mean that's something that maybe like would be in a pamphlet, like like utopia, write the same language on both sides, and of course like it's not always quite that simple, but there are some significant advantages to that approach.
You should advance.
Sorry?
I think we have each of those points in slide form. Yeah.
No.
Yeah. So.
VMs. Okay. And so one thing that's kind of really interesting to note about JavaScript is that there's been like really smart people competing on making a better JavaScript VM for years, right? Like, so you got Google, Apple, Microsoft, Mozilla. Am I missing anybody? Opera. And so this is a lot of development resources being thrown at like just making JavaScript run faster. And if it's not faster than language X today, there's a good chance it will be eventually because it just keeps getting better. If you were to compare that to other open tech like Python or Ruby, the amount of people working on making that VM better is significantly less. There's a lot less like money being put at it, and there's less competition because there's a lot of like really legitimate competition happening in the browser war. And another point in that, even though like Node uses V8, JavaScript's really kind of one of the only runtimes with multiple implementations that are actually in production. And there's a lot of different VMs in other languages, but not ones that are really battle hardened in production the same way that JavaScript is. So that's like an advantage that JavaScript has over some other.
It's not even like it's done yet either. So Google kind of started the arms race here with V8, and it was Lars Bach's team, the guy who, did the JVM, and they got V8 to a point where they're like, okay, this is fast enough, and Mozilla and Microsoft and everyone else is now caught up, and so all these JavaScript VMs are fast enough. Now they're not faster than C. They're probably not even faster than Java or .NET code compiled, but maybe they are in some cases. But they're most certainly as fast as Ruby and Python and good enough for most jobs that you're going to do. If you need real raw performance, you're probably going to sit down and write that in C or possibly even ASM. So that's something to note. The interesting thing about JavaScript itself, though, is that the programming model is evented almost all the time. And that came out of the browser. And this is where async comes in.
Yeah, I think this is actually a really important thing to understand about the advantage of Node.js or JavaScript on the server. So Ryan Dahl, the guy who created Node.js, he didn't go, okay, I want to put JavaScript on the server. What he started with the premise that I/O is not done properly, and that was his thesis, was that I/O shouldn't block, essentially. And we have all of these mature languages out there, and they essentially all block on I/O, or that is the default behavior. And so that's how everyone understands how to program, that you need to talk to a database, you query the database, you wait for the result, then you do the next thing. But the VM is essentially doing nothing while it's waiting for that database query to come back. This is really, really profound in when you start to look at the anatomy of web applications, because web applications is almost entirely I/O bound and not CPU bound. So we're always talking to a web server and waiting for the response, talking to a database and waiting for the response. So the majority of the time, the VM isn't doing anything. So Node.js, if you go back far enough in the repo, you will actually see you'll actually see that it was a Ruby project. It was a VM for Ruby originally, and what Ryan wanted to do was he wanted to make a non-blocking I/O system, right? And he realized that he was using the wrong language. That JavaScript is actually the perfect language for doing this because it already has an asynchronous property to it, an evented property, where people were used to saying hey, when this button gets clicked on, execute this function, right? And he realized that whoa, without a lot of work, people already understand how to do this. And so he then changed the project to use Ruby instead, but the premise of what wanted to be achieved, JavaScript.
Yeah.
But what he wanted to achieve was a non-blocking I/O runtime.
Something to point out here too, this isn't unique to JavaScript or even Node. All languages have these types of constructs where you can do evented programming. You've got Twisted for Python. Ruby most certainly has something. Java probably has something too, especially now that it got lambdas.
Yeah.
So this isn't that you can't do this in other languages, or not even necessarily that you shouldn't. It's just JavaScript, you kind of have to, just based on the way the language grew up.
Yeah, and it had it was seen as an advantage that this was a clean slate.
It was the first design decision JavaScript had that was oh, that's good.
Yeah. So it's that's just a really interesting thing to note. Npm, it's the package manager on Node, and it's the unsung hero and quiet achiever. It's basically so Node came around as this JavaScript runtime, and then a whole bunch of people were okay, we need packages, we need a way to share modules, and And as Brian pointed out, like they made a really intelligent decision in the beginning to not choose a package manager, and they just let the community like suss it out for themselves. And one kind of bubbled up and emerged as like the way to do package management in Node, and then it eventually became blessed as like the way to do package management. But NPM is an incredible package manager, and in many ways, like I would say at this point, like it's what deters me the most from using other systems. So like I like writing in other languages, but when it comes to putting something in production or managing like a project, it's NPM that really helps keeps me most attached to it.
One of the most interesting things about JavaScript, another fatal design flaw, is that there was no concept of a module ever. So there's no idea of creating a package of reusable, shareable code except for a script tag, which effectively just pollutes the global of the web browser. And so JavaScript was pretty shitty for reuse. You just had this globals all over the place, and it was creating a mess. Interestingly, with NPM, because that JavaScript never had a package manager, Isaac and Ryan Dahl and all the Node core got to sit down and say, okay, what if we could just invent our own brand new one and look at the past and see what other implementations have done. And so they took a look at like Java, how did that work? And Maven, they were like, okay, how does that work? And they had a look at Python, and they were like, well, how does all four of these things work? And they looked at Ruby with bundler, and they're like, how does that work? And they realized that all of these different language implementations had an interesting property that they shared, that once you had a package, it was global. And so NPM introduced one idea that I think makes it stand out way beyond every other different type of system that you see today, is that packages are lexically scoped to each other. And this means that you can have a package that depends on two different versions of the same package, and they won't conflict with each other. So at first, this seems like really unintuitive and weird, but once you start digging into it, you realize that this removes dependency hell completely, and it's a significant change. Otherwise, NPM is basically like a Maven. I mean, it's just installing stuff from the internet. But how those packages get loaded is deceptively simple and really, really interesting in the results.
Yeah, and disk space is cheap, so utilize it, I guess.
That was the original thing. People were like, oh, there's going to be two versions of this package. It's going to be such a huge waste of space. The average Node package is like 10 kilobytes. Yeah. We can afford that now. This is another little bit that comes into Node, and we're not going to touch on it too much, but it's something I like to point out to people. So streams are also a language construct that we see in every other different programming environment and platform today that are totally common. You read stuff in, and you might have a 10 terabyte file. You're most certainly not going to load that all into memory unless you have a crazy awesome computer and parse it. You're going to have to load it in chunks. You're going to have to stream it. That's normal. That's cool. Node found, because of its evented nature, that it started to stream everything. And slowly over time, and this was a really interesting kind of development, it ended up realizing that all over the libraries, from HTTP to file libraries, dealing with sys to crypto, all these different places they were streaming, and all these patterns started to emerge. And so Node core stepped back and went, whoa, we're streaming all over the place. Why don't we create a stream primitive? And so this is one of the things that really sets Node apart from all other implementations of streams, is you can compose streams from different things. And so when would I want to do this? Well, maybe I want to read a file off of disk, and I want to zip it, and then I want to send it down HTTP. I want to gzip. In Node, you can do this in a one-liner where you're just piping one stream to another. You can't do that in any other language.
Yeah, that's right. And just like the non-blocking I/O, like other languages do this. Like they all offer streams, but Node kind of did a really good job of embracing it. And this is something that happened over time. This wasn't like from day one, like streams were there. It just like
it emerged.
It emerged based off of the patterns of how people were writing libraries, and then pretty soon it was just like you're piping, just like in Unix, you're just piping like data through, right? So there's really some nice Unixy properties to how you write in Node, and it's kind of interesting that it uses JavaScript of all languages to embrace that.
Oh yeah. So I figured in the middle of all this like Node.js and JavaScript love fest, we'd just throw in that JavaScript is definitely not the perfect language. It's got a lot of warts. And I think we were still working together when WTF.js came around.
Yeah, yeah.
So WTF.js, this is like a little sideshow for you guys. So can you guys read that in the back? Okay, cool. So I'm going to jump into Node. Node has a REPL. So I can do JavaScripty things in here, like I can, I'm a string. Instance of string, so that worked. Not a number is equal to not a number. 0.1 plus 0.2.
0.3, obviously.
0.3 in a little bit. Actually, all languages have that property. So along the way, as we were doing a lot of this JavaScripty stuff, we realized that JavaScript's actually kind of terrible. And I created this site. That doesn't want to load. Oh, no, it did. Called WTF.js. And so I started collecting these things where whenever JavaScript just made me go, what the hell is going on? Oh, like, here's another classic for you. Array is equal to not an array. Maybe another time I'll get into why that happens. Yeah, so JavaScript is far from perfect. And unfortunately, when you embrace this stack and you start doing web programming, you're going to have to learn all these edge cases. This isn't a property that's totally unique to all programming language, or this isn't just unique to JavaScript. Every programming environment has its warts. Just JavaScript has a really big collection of them that you can draw on that's kind of unique. You should talk about this.
Yeah, sure. So we're gonna go through a full stack, but static site generators are, because of just the web being embraced more for like things like Apache Cordova and building web applications, there's kind of a trend that's emerging of just like, well, what if your front end is just completely static and that gets delivered to the client? And the client can cache that using app cache manifest, or it can get packaged up on a device so that it's like in the app store. And then when it gets invoked, it just talks to an API, right? So because of this approach, it's so decoupled, which is really nice, that static site generators are just kind of really taking off, and they're being developed on a lot. They're kind of like the new web framework. Everyone's built one. And it's really something that should be in everyone's tool chain. Everyone should have a static site generator that they go to. It's indispensable to have one.
Yeah, so two pieces that make this interesting, transpilers and asset pipelines. Transpilers is a fancy way of saying we're going to turn one language into most likely JavaScript at the end. And asset, not necessarily JavaScript though. A good example would be Sass, turns into CSS at the end. And so these are just sort of like slightly higher level languages that give us, usually afford a lot of productivity benefits. Asset pipelines are just a way to stream through different types of transpiled languages that ultimately end up as a bundle that you view in a web browser at the end of the day. Hybrid dev. I used to hate this term. I don't know where it came from, but it's kind of what people call things like PhoneGap and Apache Cordova. The idea of hybrid development is that we're going to take the web stack and we're going to bundle it into some kind of native shell and possibly give a plugin API so you can access native features. Basically, that's all that is. So this is another piece of the stack that our tool chain that we're going to do. So this is where we get into building an app.
Yeah. Okay.
You ready?
Yeah. Well, let's talk about the problem we want to solve.
Oh yeah.
So
we're Canadian.
Yeah. Anyone here hockey fans?
Oh, no.
Wow. Yeah.
Wait,
wow.
who here is from Chicago? Hawks. You're in the frickin' playoffs.
I thought there'd be like jerseys and everything going on at this point. Yeah.
Anyways, we bleed maple syrup and watch hockey every day.
Yeah, so being Canadian, we're obviously interested in the playoffs. We're going to be watching the game tonight, and yeah, like there's no NHL API thing, and that kind of bothers me because I like code and APIs, and I like hockey, so I want to consume both those things at the same time. So that doesn't exist, so we're going to build that today. And we're going to start by solving that problem by screen scraping the NHL.com website and exposing an API for gathering statistics on players and how they did from season to season. So
After we build that, we'll deploy that little bit as a node module so other people can use it. We'll throw an HTTP interface in front of it, and then you'll build a static site on top of it.
Yep.
And then I'll turn it into an Android and an iOS application.
Yeah. So what we're going to show you is essentially an entire stack, an API, a client that consumes it, and then distribution to the app stores, right? This has got to be like, I don't know, 3/4, 9 months worth of work. And
I mean, unless you're
if you're doing it properly.
if you're doing it properly. If you're going to build an iOS app, an Android app, an API, negotiate the rights for that API with the NHL. Yeah, so I don't know. It's an interesting use case. Anyway.
Yeah. So what we're going to do is very ambitious, and it's dense, and so we apologize for that. But just enjoy it, watch us stumble, and yeah, it should be fun.
Yeah, from here on, I think we're live coding basically. So,
Yeah.
You're driving this part, man.
Okay.
And I'll stand and do color.
I'm going to talk about one thing first.
Yeah.
So with this particular problem,
Oh. You want me to go back on?
I want you to go to NHL website.
Okay.
So this is, I think, a really good problem for JavaScript. And the reason for that is because we're going to screen scrape this website. Go to one of these. Go to Blackhawks.
Like this.
Up top.
Oh, yeah.
One of those.
I never know where to go on this website. I'm just like, information.
Where's the API? This is a big ad.
Just this massive ad. Buy tickets to a game that's sold out. That you couldn't afford anyways.
So this to me is an ideal use case for the stack that we chose. And the reason for that is because what we're going to be doing is we're going to be pulling down the HTML for these stats. They have these tables. And we're going to be parsing the DOM and extracting it and exporting it as JSON. And you can do this in any language. But the reason why JavaScript is particularly good for this use case is because we can actually just put the DOM on the server, and then we can parse it using jQuery or any kind of like DOM manipulation parsing library that we've been using for years in the browser. So it's running the same code path. And these libraries are battle hardened. They deal with like the quirks of the DOM and like all the different browsers. So we can trust that these are good libraries for parsing the DOM. And like I say, these libraries exist in every language, but I think it would be hubris to expect them to be as mature as what we've been running in the browser on hundreds of thousands of web pages. So let's dive into it.
Yeah.
Okay. So what we're going to do is we're going to start with like npm is it just has this init command that creates a package.json file for you. There's nothing like super magical happening here. It just is helping me create a file. So we'll call this NHL. And we're going to start 010. That's where I like to start. NHL API. That might work. And then the entry point is the file that it executes when this library, this directory gets required. and we'll just we'll keep that as index for now. And then the test command, I'm going to have it run mocha test, which mocha is just a test runner, and then no Git repository for now. NHL, the cup. All right. Author, Brock Whitten, Brock at glowy.io. And license, just use MIT. Is this okay? So all we've done is created this package.json file. So this is going to give us, like, when we want to publish to npm, which is the repository, it kind of, this is what it'll name the package, is npm. It doesn't name it after the directory you're in. This is the version that it'll give it, and etc. And so this is kind of important here, which is the file that it's going to execute, which we want to create that file. That's important. And then we need to add dependencies to this project. So let's do that next. So I'm just going to now hand edit this file a little bit and add dependencies. Bri, let me know if I make typos.
You got a trailing comma.
Yeah, I do. So we're gonna, like I said, we're gonna be parsing the DOM. So what we need to do that is JS DOM. There's a few others that you can use. This is one that I'm familiar with.
Cheerio is another one that's pretty popular. There's no right or wrong answer. npm has thousands, probably hundreds of thousands now of packages.
Yeah.
And it's super searchable, so you can pick and choose what you like.
And what else do we need here? We might do Redis. We'll do some caching in Redis because we don't want to get shut down from the API. If they see like all this traffic going to screen scraping their site, they might shut us down. So we want to be a little bit discreet in case we don't want to hammer them too hard, right? So I'm leaving these strings empty, and that's just going to take the most recent version of these packages. But you can explicitly, and you should explicitly specify what version you're using. Now we specified Mocha as our test runner, so we're going to want to require that, which we're going to do dev dependencies.
It's kind of a nice feature of Node, or of npm anyways, that you can specify dependencies for dev time and dependencies for deployment time. If you're using this library, you don't need to run the test, so we'll just throw Mocha in there. This is just a regular old manifest. It's just a simple JSON file. There's nothing actually all that special going on here. And now Brock's just going to run npm install, and it's going to go fetch all this junk off of the internet. And it's going to fire it into a folder called node modules. So if anything is in node modules, it's considered global to that package.
So like I said before, we want to create this index.js file. And we want to create a test directory, because we're going to write a few tests to make sure that our API works. So touch basic.js. Actually, I'm going to stay in the root.
So run npm test.
OK.
So when we added that test into the package JSON, when it said scripts test and it said Mocha run the test directory, what happened there, now npm just got a magical command called test, which will run, actually cat your JSON or your package JSON. So when you run npm test, all npm's dumb. It doesn't know anything. It's just going to run Mocha test for you. It's a nice little shortcut, but it's a subtle thing, because what happens now is no matter what testing library Brock chooses to use, every person consuming this library is going to know to run the same command to run the tests. They don't have to learn a new test runner. They don't have to learn a new language to deal with it. So every node module you now download or encounter in your journeys throughout this ecosystem has the exact same invocations, whether or not the underlying implementation is the same.
Yep. So if I run which Mocha on my machine, it doesn't return anything. So what this does is tells you, okay, where is Mocha installed? And well, we've installed it. We just ran it, but my system doesn't know where it is. So why did that work? Well, it's because I ran npm test. And what npm does for you, I'm going to open this in Finder and just show you this code. Hopefully you guys can see that okay.
Zoom in with the...
oh, my machine doesn't do that.
Oh.
Okay, we'll just ls-la node modules. So in the node modules, actually, I'm going to show you one more thing. So this is our project. We got this node modules directory. So what npm did when we ran npm test is it took what we specified as dependencies in the package.json, and it installed it in node modules. Now, this is really nice relationship between npm and node. When you run node, it actually doesn't need npm at all. Like npm, all it does is go like, okay, I'm putting the dependencies here, and then node knows how to run it. Node has a relationship where it looks in a node modules directory for whatever you're requiring. And it's going to recursively go all the way up the tree until it gets to the root of your system.
Run npm ls.
Oh, yeah.
So this is actually kind of cool. You can see we've got a whole lot more going on in here than we knew.
Yeah.
We only installed, for example, Mocha, or actually JSDOM is a good example. So we only installed JSDOM, but JSDOM has its own dependencies, such as CSS object model or whatever.
Mm-hmm.
So this recursive lookup path means that we can have multiple versions of the same modules living in our tree of dependencies, and they don't conflict with each other. That whole lookup path means that everything is lexically scoped, which is a super powerful and nice feature. Yeah. Other languages have tried to replicate this with different sort of bundling hacks, but generally the term dependency hell applies really well to all other languages.
Yeah, and so like JSDOM is requiring contextify, but contextify has its own dependencies which are underneath it. And so like it needs nan 1.0.0, and there could be another like dependency that also requires nan, but version 0.1.2 or whatever. And so they're totally discrete. This guy isn't going to use that version of nan. He's going to use his own if he needs it. And you might be looking at this and you're like, holy crap, that is a lot of code. That is a lot of dependencies for something as simple as what we're about to do. Well, something to note is that the Node communities really embrace the philosophy of writing tiny little modules, like write a module that does one thing and does one thing well. And what's kind of interesting side effect of that is you'll have these node modules that haven't been updated in like a year. You're like, oh well, this project's been abandoned, right? But it's just that it's done more or less. Like it just works. And so although this looks like a lot of dependencies, it is
probably not much code.
It's really not much code.
They're probably each one function kind of thing.
Yeah.
So we've hit the break time.
Okay.
And I'm debating, do you guys need or want the break?
We should take a break, but let's
well, or we could put
have our own break schedule. You guys figure out a logical
what? Yeah, because I think this
okay.
Let's get the tests passing, and then we'll take 10 or something, because it'd be good to get some real running code happening.
Sounds good. So I just want to point one more thing out, because I noted on Mocha not being installed on my machine. But when you look in the node modules directory, it's going to, you see Mocha here, but Mocha has this bin directory, and
that's also kind of magical.
And Mocha is right there. So this is an executable. And when you run npm test, it actually it takes the bin directories in these modules and it adds it to your path so that it can be executed just for that runtime. Once the script is finished executing, then it's all finished. But that's how that works. So let's actually write a test, a few tests, and I'm going to open this up in Sublime. And
Bump your font, man.
oh yeah.
That's good.
All right. So we're going to go like, we want to start by requiring the library that we're about to test. So we're calling this NHL and require, we're just going to go back one directory. If we were installing this library, we would say require NHL. But what we're doing here is we're saying, oh, we want to require this directory, and it's the npm.json which tells it, okay, I want you to load the index.js file.
Oh, package.json. Yeah, so remember when we had that main equals index.js? When you use relative pathing like this, when it encounters a package.json, it'll use whatever it says for main for its lookup. So you could have whatever you want in there. You could also be explicit. You could walk out of this directory and include index itself if you wanted to. Sanity test should exist. Yeah.
Is this using require.js?
No. We're using require.js is a client-side module loader. Node has its own module loader. It's kind of loosely based on CommonJS, which is sort of a competing spec with AMD require.js. You can actually use require.js with Node. No one really does, though. So the idea of there's two different competing specs for how you would write a module using kind of classic JavaScript. This require style is supported by both. At the end of the day, they both kind of get compiled to the same thing. There's some semantic differences that people debate. One nice thing about require.js is that it basically uses functions all the way down, so it's completely asynchronous. Node's CommonJS style here, when we actually do that first require, believe it or not, it's blocking. This is like one of the heresies of Node's own architecture. Inside of that require statement, we stop execution and we load this thing, which is like terrible for Node. But it's the one spot where most of the Node community is like, okay, this is worth the performance penalty this one time, is if we do this nested require thing where you'd have require and pass it a function, the code just got too ugly.
Okay, so we have two tests written. One is saying, okay, this library should exist, which we required it there. And because we did have an index.js file, it was like, okay, that's cool. You have a library called NHL, which we required. And then I'm saying, okay, well, we should have a function called team, and that's going to grab the statistics for a team. This is something that we haven't implemented yet. So we deliberately wrote a test that fails, and we're going to make it pass by implementing it. So if you're following like the strict TDD process, you want to do the minimum to make something pass, and that would be export.team is equal to new function, let's say, and it breaks. Exports.
Yeah.
Done is not defined.
Oh, you didn't pass it in the test.
Okay. So we have a passing test, and typically what you do is you just write another breaking test that gives it more functionality and then implement it. But I'm going to skip ahead a little bit. And
this exports bit's kind of important. So Node modules expose a few globals. Exports is one of them. Exports is the interface that you want to share with the world. When someone else requires this library, whatever's been exported will be available on that function.
so I'm just going to steal this piece of code. This is just one function. And let's see if this passes the test. Okay, that works, and we should. So we're actually really close to having this done. I'm gonna write another test just to make sure that it's should return team stats, and we're gonna execute NHL team and say, okay, I want the Blackhawks and we'll go 2014, 13, and 2014 season. So the reason why, that's just the format that the, if you go to the, this is the URL, which it takes a parameter of season. So I'm just copying the same format, and we're passing that through. So just to walk you through this code, we're requiring JS DOM. So that's saying, hey, I want a DOM on the server. And jQuery is just a string saying where jQuery is, which we'll just use the CDN. And this is the URL that we're going to scrape. Now, we execute this JS DOM, and you'll see that we pass in the URL of what we want to scrape, and when it takes this array, and that is the jQuery file that we want to load. It most likely uses jQuery, but we don't want to trust that. We want to make sure that we have whichever library we want to use. So what this does is it pulls down all that HTML, and then it injects jQuery into the page so that we have access to it. So even if you want to screen scrape something that doesn't have jQuery, that's no problem. Then what we're doing is we're doing like,
actually, this is one other thing to throw out there just to point out. This is very much the JavaScript async style. So one way to look at this code, you could say, oh, I want this result to equal the execution of this function. But inside of JavaScript land, we're going to pass a function to execute after we're done grabbing all this information. So this is like when we're finished calling jsdom.env, execute this function with either an error or the current DOM window. So it's a little bit weird, but that's pretty much the Node style. First parameter of callbacks in Node are almost always errors. And the reason for this is you want to deal with your errors before you go and do a whole bunch of parsing later. If there's some kind of error, it's going to get passed in through, and you're going to want to deal with that first. And Brock's following this exact same style down here where we're passing functions all the way down. You kind of don't want to go too deep in that. If you start building the pyramid, sideways pyramid of doom, that could be problematic. There's all kinds of tools to deal with that. It's just the nature of the language. Is it bad? I don't know. Once you get used to it, it's fine. It's just a property of asynchronous programming, really.
So we're hoping to get an array back once we do that DOM parsing, and we build up this player object, and then it returns an array of players. And just to make sure it's working, we're going to just grab the first item. Should have a name, should have a sweater. Call them sweaters, by the way, not jerseys up in Canada. And we want to get the goals, assists, and points.
Jump over to the implementation real quick.
Okay.
We should just finish very quickly what happens in here. So
Is that big enough?
yeah, or bump it up maybe. Yeah, that's good. So whatever, we call jsdom.env. We give it a URL we want it to call. We tell it to inject jQuery. And then call this callback once you've done your business. If there's an error, we're just going to blow up. Otherwise, we're going to grab a reference to jQuery. And then from here on, this is client-side programming, but we're running it on the server. All we're doing is grabbing a bunch of TDs out of a table. If you've done any client-side programming, that looks familiar. It's pretty gnarly, but Brock's just building up a chunk of JSON. And then at the very, very end of this, you'll see callback players. At the very top of this module, if you scroll up a bit, you'll see that we take a callback as the last parameter. So
just to show exactly what this is parsing, let's open this up. I'm an Euler fan, but it serves the same purpose. So we've got all these players, and then we've got another little table of these guys, right? So this table, if you look at the DOM, it's this, like it's got a class of .data on it, and we're saying, hey, we want to find the first data, we want to look at the table rows, and we want to ignore the HDRs, which is the headers, right? Like we don't care about the header, we just want the actual data. So that's like what's going on there. And this maps to that data, and let's run this test. And hopefully it works. It's failing. Could just have timed out because it's OK. So we're passing. We actually have an API now. Like we can expose this, and you haven't seen any actual JSON. So you're like, how do you know it works, right? Well, that's because of the test that we wrote. But just for extra measure, we're just going to be. I'll just console.
actually, no, jump into the REPL and grab it and require it.
OK. So we're going to go node, and var NHL is equal to require.
You could do // yeah.
That. OK, NHL. OK, we have a function called team. Let's execute it. We'll pass in Blackhawks.
Console log.
And I want to see if if the second parameter is optional.
Oh, yeah.
It's not. OK. So we'll pass in 2000. No, you know what? We'll make it. We'll pass it in. We'll make it optional if we had more time. 2011, 2012. Does anyone know who led the Blackhawks? 2011, 2012?
Jeez. Yay.
OK. I'll tell you because we have an API.
Tags? Oh.
Marian Hossa.
Hossa.
Okay, he had played 81 games, had 29 goals, 48 assists, 77 points. So we have an API.
I thought that'd be tapes for sure. No.
Yeah.
Anyways.
It was Taves the next year, and then Patrick Kane this year. Well, let's see. Let's see who. We're going to see this year. We'll go with 12. Or sorry, this is last year, which is boom, boom, boom.
Kane.
Kane, Taves, and Hossa.
It's always
and
one of those two, eh?
those guys battle it out, eh? And now let's check this season, which I'm pretty sure was Patrick Kane.
Yeah.
Whoops.
It's that beautiful hockey hair.
Yeah. It's like Joe Dirt. Oh, Marian Hossa.
Hossa and Seabrook. Weird. Cool.
Oh, this might be games 13. This is the playoffs. All right, so we got a little bug in our thing here. We didn't account for playoffs, but yeah, it's a valid JSON payload, so we're happy enough, right? Ship it.
Ship it.
All right.
So I think that's a good spot for a break.
Yeah, I think that's perfect. So during the break, we'll deploy this so that when we come back, we'll have an API that's live that we can then write a client for and consume the API. So just to recap, we've got our library that we wrote here, which NHL. So what it is, so this is what we put together, right? So just like a cooking show, we put the turkey in the oven, and it's like, ding, it's done right away. So we got this up online already. And I know we required Redis in our dependencies to do some caching. That's already done, and it's up and live. But I'll just show you that code just because, satisfy your curiosity there. Which we wrote this NHL cache, and you'll see that it also exports a function called team. And all this does is require that script that we wrote in the previous session, and it takes the JSON payloads and it caches it for
One thing that worth pointing out here,
2
and this is kind of
hours.
fun, so Brock mimicked the exact same API for exports.team. So he takes team, season, and a callback. And the other nice piece is that he's completely discreetly separated the concerns. So he doesn't have to go in and test whether or not the NHL library works. He knows it works. It's in a different repo. It's in a different issue tracker. It's deployed to a different place. And now that one discrete little chunk of code can go live happily by itself. And it only does one thing and one thing really well. It goes and gets NHL scores. But that isn't good enough because we need some caching. So we added this Redis layer as a kind of second library on top of it.
Yeah. And so it calls it, passes in the team and the season, and then what it does is it just sets it as a JSON payload, caches it for 2 hours. I'm just like incrementing a thing so I know how many times I hit their API, and return the players. So when this gets fetched, it's going to first try to get it, and then if it doesn't get it, it does the expensive thing, puts it inside, and then it'll just hit this. I'm also seeing how many times the cache gets hit. So what we have here is a library that scrapes the API, but we actually didn't do any HTTP in the last session. So I'll just show you that code because it's really straightforward.
You'll notice too, and this is very much in kind of the Node philosophy, all these modules are around 50 lines of code. We want really small, tight pieces of code that are reusable discretely. And so this is the whole API, an entire HTTP API, which is a whopping 25 lines of code.
Yeah, this is very common. And like realistically, what you're seeing here is like, if I were doing this for reals, it would be in 3 different modules, as Brian points out. The HTTP layer should just require the NHL cache layer and be its own module. So that's why you see all those modules when we listed those out. But what this is Express, which is the HTTP part, and I'll just walk through it really quick. So we're saying require Express.
Express is kind of the Sinatra of the JavaScript world.
Yeah.
It's one of, anyways. There's many of these libraries. This is one that is by far and away the most popular. Most Node developers, when they get started anyways, are using this. Interestingly, its API is not that far off from just a core stock Node HTTP API. It's got a few niceties built on top, but it's a fairly thin layer.
Yeah, the most notable thing that it gives us is like a router, so we can do this sort of stuff. So if just / or the root gets required, then we're just going to say, welcome to the makeshift NHL API. And then this is really our only API endpoint, which is the team and the season. We're adding a couple headers here to allow cores. Do you want to explain what cores is?
Yeah, cross-origin request policy. So cores means that we can call this API from other domains. So this gets around the web sandbox. Or it's basically saying this server is cool with any other server calling it, or any other HTTP request from any other domain is cool with us. So
I noted before that we didn't have a default, which that library probably should. I hacked it on the HTTP layer. Maybe it should be in the other layer, but that's okay. If season isn't being passed in, we're just going to set it to 2013, 2014. And then we're going to, when we reply, we're going to say that we're replying with content type of application /JSON, so that the client knows that it's a JSON payload. And then we're going to send it back. And if this returned null, then we are going to say, hey, stats not found, and reply with a 400. Finally, last of all, a catch-all. So if you try to hit a different path, we'll just also reply with a 404. And then finally, the last step is just saying like app.listen on this port. The port is specified up here as a variable. And we're just saying, hey, if you pass me a port as an environment variable, then use that port. Otherwise, we want you to start on 2000 or 8001. Any questions there? OK. So this is now live. And here it is. So nhl.chloe.io. We can go to Kings, Blackhawks. Whoops. Oh, there it is. Here's that Blackhawks payload. Man, that's fuzzy.
It's fast.
Yeah, it's fast now once it hits the cache. If we hit like Flames, this is going to be slow on the first call. But then if we refresh, it's fast now because it's hitting the cache. So that's all deployed. And now we want to consume this API. So let's do that.
So that's the end kind of our server-side programming portion of the story. Now we're going to start building clients.
So we talked about JS. So we talked about static site generators, and this should now kind of come full circle and see why like a static site generator or something that allows you to create HTML, CSS, and JavaScript in a way that's sane and maintainable becomes really valuable at this point, because what we can do is we can write that, and then we can, as we'll demonstrate later, we can put this on, wrap it with Phonegap, or we can deploy this as a static website, which is really easy to scale, really portable.
One of the jokes we were telling years ago, static websites are web scale. So people seem to forget this. Like WordPress is a wonderful example of a static website that is not web scale. I mean, you got to add all these weird caching layers. There's like 60,000 lines of PHP, and all this thing is really doing is showing you web content. It's kind of ridiculous. So static sites sort of took off because of Jekyll, I guess, and GitHub Pages. But the concept is great because you can deploy these to S3, you can deploy it to GitHub Pages, you can deploy it to something like Harp, and all you need to put in front of it is a simple web server, maybe even a caching layer if you want to, and it's going to be blazing fast everywhere.
Yep.
And consumable by anything with a web browser.
Who here is familiar with Jekyll? OK.
Yeah.
A few people. So yeah, Jekyll's one of the more popular ones. I'm just going to show it.
Jekyll's pretty sweet.
Yeah, Jekyll was written, I think, in like 2005. So it was really, I think Tom Preston Warner wanted to create a blog, and he's like, hey, I just want it to be HTML, CSS, and JavaScript. And it seems it's very approachable to just like, OK, well, let's just write HTML, CSS, and JavaScript. But which is fine almost. But the part that is not fine is basically a show blocker or a showstopper. The main reason is like, OK, so you hack together one page, and that's going to work out just fine. But as soon as you have like a second page, and you have to copy your nav over, you have to copy all your headers and all that, like there's no way you're going to really have a very enjoyable development experience, first of all. And second of all, you're going to have oddities, and like pages will be different. So just even be able to wrap things in a layout and be able to just write the pieces that you need, that alone is extremely helpful, even though all you're really doing is stitching together some HTML, right? So that's where this comes, and GitHub supports Jekyll by default. It's written in Ruby. It's good. The biggest downfall, I would say, is that you have to deal with like the Ruby dependency situation and like
It's slow.
yeah, and it's really slow. So what we're going to use is a very similar tool that's written in Node.js. So we're going to stick with the JavaScript stack, and for all intents and purposes, this solves the same problem. It's faster, and it gives you a few nice things like automatic pre-processing. Who here is familiar with like CSS preprocessors? Okay, a few. And what about Jade or CoffeeScript? Okay, a few as well. So what's kind of happening is with the value that HTML, CSS, and JavaScript gives you, that's a really nice way to deliver and have as an end product, but it's a really difficult way to build really mature applications. So there's a whole bunch of languages cropping up that that solve this problem. Like for example, with CSS, even specifying a variable, like your background color is green, and being able to reuse that green in other CSS parts of your CSS file, or even in other CSS files. CSS doesn't offer you that. And like variables happen to be extremely useful when you're programming, right? So there's a crop, there's a few.
Just build it. Just build it.
No, it's cool. I want to explain it. This is important.
Okay.
So there's these languages. One's called Sass, one's called Less, and there's a few others. But all they do is they give you these. They fix some of these problems and they export to CSS. So what Harp does is it gives you that automatically. So we're going to go to the desktop, and I'm going to create a project, Harp init. I'm just going to call this foo.
Oh, how did you get Harp?
Oh, yes. So Npm Install. This is published to the Npm repository, and Npm Install will just put this. The -G makes it a global package, which means that I can run which Harp, and it goes in my user local bin file. So I initted a project called foo, and this is a Harp app, and I'll just open this up. It's actually a shame that when I bump the font size, you don't see the sidebar get bumped, but it looks like this. We have a index.jade file. That could be an index.html file.
Or Markdown.
Or Markdown. And main.less.
Or index.html.
But the takeaway here is when I run Harp server, this could just run a static site. But it gives you these other languages, which are kind of nice. So if I go to localhost 9001, 9000, sorry. We get welcome to Harp. And the output here is HTML, right? This is what we expect. But if we look at the source files, we're writing in this language called Jade, right? And what it does is it just gives you a bit nicer syntax, so you don't have to go like H1 like this. Welcome to Harp. But so you're probably thinking like, okay, well, what's the big deal? Like, that's not that difficult. Well, when you get into like writing a lot of HTML, like closing divs is kind of pain in the ass, and you always miss some here and there. And like, you can take this or leave it. It's not super important that you use this, but But once you get comfortable with it, it is a little bit awkward going back, and you see the value. And it's not like writing HTML is hard, but it is time consuming, especially if there's that trailing div tag that you can't find. So all this is that static site layer, and we can take this, even though it will run as a web server and it will do the transpiling on the fly, we can also go Harp compile, and we'll go back a directory called www. And now if we look on our desktop, we've got a www directory, and that site just got compiled down to these three resources. We have a main.css, we have an index.html, and we have this 404 page. A convention in some new lately is like a lot of web servers will recognize a 404.html file. That's just like a convention. That's nothing really special, but it's becoming commonplace now. So here's our static site generator. This is the tool we're going to use to build a client to consume our API. So I'm going to shortcut this step a little bit because I have it built already. But just to show you guys where the API is, we have it at nhl.chloe.io. You can go Flames and Blackhawks, right? And now we need a front end that can be deployed in a completely different place to consume this API. So at harp.io, there is a way that you can host these Harp applications in your Dropbox directory. So we're just going to create a new one, a new application.
You don't have to do this.
You don't have to do this. You could deploy this on S3 or anywhere. But we've got we'll pick a domain of nhl.harp.io. And we're going to tell it, I want the starting point to be NHL client. I'm going to show you what this is. So this is a GitHub URL. You probably can't see that in the back, but I'll just show you the page. .com. And here's this Harp app. And this is already pre-baked that consumes that API. Inside it, we've got an index.jade file. We've got a CSS directory that has Bootstrap in it. But what's interesting to note here is that this isn't the bootstrap.css. This is the actual source files of Bootstrap. And Harp is automatically going to compile this on the fly for us and export that one single CSS file. And what's valuable about that is that we can come in here and we can edit some variables and change colors and do all that. And Harp will just take care of that for us. So let's create this app. NHL. So what we're probably going to see is my Dropbox. Let's open this guy. Here's this NHL app. And this is being created right now. So these are filling up. CSS directory. We're almost done, 66%.
Is it tethered or is it?
It's tethering.
Yeah.
This is all going through a phone.
This is going through my phone in my pocket. Future.
Yeah. Okay. So if we go to nhl.harp.io, if everything went smoothly, we should have an application. So, man, it looks bad. Okay. So all this is that we use that static website. We got the Blackhawks, we got the year specification, and this is just like a really simple Angular app, which now is in my Dropbox, and I'll just open it up in Sublime.
Anybody doing any Angular dev here? A couple people, yeah. Seems to be the new favorite these days. There's a lot of these tools that are out there. There's no real right or wrong answer. We're not trying to tell you to use Angular.
Yeah, I'm really new at Angular, but it's pretty interesting. So the application we're going to show you, this is the entire thing, apart from the CSS. And this JavaScript function. So let's just show it running. This just allows us to go to the Kings, and we're saying Kopitar. And I'm just outputting the payload for each player, but it's that same JSON payload, right? You know, with your imagination, fill in like awesome client that is really fun to use. And
you guys are probably familiar with IMG tags and stuff, so we don't really need to show you that.
Yeah, we don't need to show you how to build a web page. Okay, but so this is a done thing. So what we have here is we have an API deployed that we built that screen scrapes. Now we have a front end deployed. These are on different domains. They're completely separated from each other. And the idea is we can have multiple clients, like not just one. So what we have here is a web page for people to use, but the next step would be, okay, it might be good to be in the iOS App Store or in the Android Marketplace, or even building a native client, and that is the next step. I think Brian and I would both like almost stop at this point. We're like, it's on the web, that's good enough, just use the web page. But it's important, I think, as software professionals for us to not always impose our opinions on how the end user consumes an application. And if the behavior of a user is, hey, I want to just go to the App Store, that's how I consume data, is I find an app in the App Store and I consume it. We want to be as accommodating as possible. And really the web is very good at this. It is the really only cross-platform platform that we have, runtime that we have. So what we're going to do here is we're going to leverage this advantage, and Brian's going to take it from here and show you how you would do this.
Oh, did you throw it in share it with me in Dropbox?
Oh yes, okay.
Yeah, so the funny thing is, despite the fact Brock being the original creators of Phonegap and me being one of the people who works on it still to this day, neither of us really want that outcome. We love Phonegap, and it's a lot of fun building for these app stores, but we don't really think that's the end game. We still want to get back to web development. We're super uninterested in investing too heavily in proprietary UIs, as we brought up in the beginning. I'll give you a great example. We recently had some partners come to us, and they had built and deployed apps. It was a major, major brand for iOS 5, and that was great. They were in the App Store. They had that discovery. They had the offline capability of the apps running on the phone itself. And when you went and put that brand's name into the App Store, they were there. And they had access to device APIs and all those other benefits. iOS 7 came out, and the user interface guidelines changed completely. And they were like, oh my God, we got to update our app. So wait, who did that? And then they realized it was a consultancy they had hired. And so they went looking for that consultancy. It was gone. So that investment into that proprietary client UI burned them badly. They now had an app that was a detriment to their business in the App Store, and they had to quickly scramble and find Objective-C developers to fix it. So you got to watch out for that. There's no right or wrong answer. Did you share your Dropbox with me?
I did.
Okay, cool. Man, programming with bagpipes. Oh, and I just got it.
Excellent. Okay, we got a monitor situation again.
No, it's fine. I'm just booting up. So this is the Phonegap portion of our project. Phonegap is a way, it's not the way, for you to get this content into app stores. Oh, get my bad language out of here. So Brock shared his app with me in Dropbox. We're finding this is a pretty common way for people to work these days. There's more than one of these solutions that are out there. Again, this is a way, not the way. So I've got...
You have to accept the invite. Those are the test files. You can delete those if you want.
nhl.harp.io? Okay,
Yeah.
well, while that's downloading, let's pretend that I'm going to install Phonegap. So again, I use Npm as well. And I would go Npm Install globally. This is a shortcut to get Phonegap. And I would also add Cordova into the mix. So Apache Cordova is the open source guts of Phonegap. They're completely interchangeable and 100% compatible. The reason we have an open source upstream is because we collaborate with a lot of other people on this software. Phonegap is a distribution of Cordova. They're always going to be compatible. There's no reason why they wouldn't be. And there's other distributions of Cordova out there too. Probably most notably now, Chrome mobile packaged apps are based on Apache Cordova. So your Phonegap app will be compatible with Chrome mobile apps. That's kind of the idea. Phonegap gives you a CLI, and so does Cordova. And the CLI's got a couple of things that are neat. So it'll tell you how to use itself, first of all. Gives you a bunch of commands. The other nice kind of neat thing about it is it'll tell you what platforms that you can build for. My machine's all tricked out and ready to go for every platform you can imagine, because that's sort of my job. But you may not have all these environments. We recently launched app.phonegap.com to sort of deal with this. So the idea of the developer app, you install an app on your phone, and then you can pair that device back to your local machine as you're doing development. And the reason this is awesome, because otherwise you have to install Node, you have to install Phonegap, then you have to install the iOS SDK, the Android SDK, the BlackBerry SDK, the Windows Phone SDK. You have to provision your devices to do all that, and it takes a while. This turns that whole process into a 5-minute thing. I'm not going to demo that because I have it already set up, but I just want you to know that there are apps in the App Store for doing this stuff. So if you want to get started with Phonegap, it really is only like 2 or 3 minutes to get going.
Yeah, doing it the OG way is easily take you a day, like just to get an iOS device provisioned and set up properly. You can burn a week getting all these things downloaded and installed. So these are really nice tools to really make that a whole lot easier, and by essentially circumventing it completely, and you can iterate and test a whole lot quicker.
So I'm going to show you on the command line. This is the OG way, as it were, how to build an app. So first I have to create an app. Okay. And now I'm going to step into that app and take a look at it. Every Phonegap app has these 5 folders. There's only actually one that's required, and that's www. Inside the www folder, we put HTML, CSS, and JavaScript. We have a plugins folder. Plugins let you add native functionality to your app. You don't have to add it. You can add it. It's not a mandatory thing. Platforms are where the native platforms are going to end up living. So Phonegap apps are native apps. If someone tells you they're not, they're wrong. So what we do is we compile a native app for each individual platform, and we'll fire them in the platforms folder. We don't hide them from you. We don't paint over the differences. It isn't a compile target that you can't touch. We encourage you to use the native tools. Merges and hooks are kind of new features. Merges lets you take assets that are static and merge them in with the WW. So for example, if I had high-resolution images that were only appropriate for the new iPhone, I wouldn't want to compile those into my low-end Androids. And so I could use the merges folder to add those assets, and they would only get compiled into Android. Hooks is a set of before and after events while I'm working with my app. So if I'm compiling it, I might want to run a preprocessor before. That's where hooks would go. So I created this test app. And I'm just going to go Phonegap run iOS. It's going to see that I have iOS. It's going to compile it. It's going to see if I have an iOS device plugged in, which I do not.
Oh, what's that typeface you got in your terminal?
Oh, isn't it beautiful?
Yeah.
It's Adobe Source Sans Pro.
Oh, nice.
Yeah. And I compiled and launched the app in the iOS simulator. And just to show that there's no smoke and mirrors up my sleeve, why don't I do the same thing for Android? Just realized I need a cable to do this. So that's just hello world, right? This isn't, we're not done yet. We just got started, really. So I would show you in the Android emulator, but we've only got an hour left. And the Android emulator takes an hour to start.
So there's some foreshadowing going on there. You might have seen that www directory when Brian created this Phonegap project. And when I was demonstrating Harp, I compiled it into a www directory, right? So what we did is I shared the source files, the actual Harp, like Jade and all that, through the Dropbox, which now is on Brian's machine as well. And he's going to run that Harp command to get the www folder into the Phonegap project. And that's going to be the basis for how we get a native mobile application.
So I'll clear this so you can see what I'm up to. Phonegap, we and Cordova don't discourage you from using the native SDK tools. If you like Eclipse, I don't know what's wrong with you, but if you do, you can use it. If you like iTunes, Apple has a version of it that works just like Eclipse called Xcode, and you can use that too. Anyways, Phonegap run Android. All these things work with or without the IDEs of your choice, and they work with the platform tools of your choice. So I'm going to run Android, and it's going to go through the same steps. It's going to be like, hey, do I have an Android SDK? Sweet, I do. I'm going to compile this app for you. And then it's going to go, is there a device plugged in? Of which there is. And then it's going to install that onto my phone, which, oops, if I go photo booth, and I'm quick enough, it'll show you this happening.
That phone's working hard.
Yeah, it is. It's tethering, and right now I'm installing APK. Oh, damn. There you go. Same app, now on 2 platforms. If I was a masochist, I'd show this to you on Windows Phone and BlackBerry, but I'm not, so I'm not going to show that to you. But it's the same thing. It's the same amount of commands. It's the same nomenclature. It's the same workflow. There's nothing really too special about what we did here. All we did was throw a bunch of web code into a fancy web browser. So now let's go take Brock's app. So he's at nhltest.harp.io.
You want the
Oh, no,
NHL.
I want this one. These two I can just get rid of, eh?
Yeah.
Okay, those guys are gone. nhl.harp.io, sweet. So I've got my test app here. This seems to be working okay. There's one magical file in Phonegap, and that's in the www folder, and it's called config.xml. I'm going to move that into the root of my project while I do some compiling. I'm going to edit it too. Phonegap gives you a network security layer, which I'm just going to ignore completely for the purposes of this demonstration. And I'm going to go harp compile. My Dropbox is out1 Dropbox NHL, and I'm going to go into the current www folder. And it's going to do that, and then I'm going to copy my config.xml into www.config.xml, and then I'm going to kill my iOS simulator, and we'll start it all over again. Compiles a little faster the second time, and sweet.
Yay.
We have an app now running on iOS. Just make sure this thing works. Let's go get the flames fast. Cool. Why don't we give this a try on Android for fun?
Sweet. So that took 6 years to build.
It kind of did. So back in my ugly mug over here.
Phonegap started 6 years ago.
Yeah, 2008. We got the same thing going on. We recompiled, we relaunched, and now we have the same app running on, well, you can see, Android.
Sweet.
Not bad. Let's get rid of that. So that's kind of cool and sort of interesting. Cordova also has a CLI. Cordova is a lot more lower level, and it has a lot more that it can do. Cordova is more like a Swiss Army knife for creating native app distributions, and you can use it for different reasons. One thing that's kind of neat about the Cordova project is there's a ton of people collaborating on it now. And if you go to plugins.cordova.io, there's about 220, no, there is exactly 227 plugins in the commons right now that allow you to access every different native feature that is available on the device. Why would you want to do this? Well, you might want access to the camera, and the regular web browser doesn't give you access to the camera. Or maybe you want to access something like the native dialogues in the app. And in fact, I'll show you a good use case for why you might want to do that. So back in my test app here, I'm just going to jump into the www folder where I have my compiled Harp assets. Now, if I was a good programmer, I would go and I'd modify Harp, and I'd recompile. For the purposes of this demonstration, I'm just going to show you something really hacky and quick. So I'm a JavaScript developer, and I like to debug using alerts. So I'm going to do an alert, right? Alert, hi, no big deal. This is going to instantiate a native alert dialog. I'm going to go back, kill my iOS simulator, jump over here. We'll do Cordova run iOS. Cordova run iOS is exactly like Phonegap run iOS. They don't do anything different. The big deal about the Phonegap command line tool is it gives you access to Phonegap build, which is a cloud compiler. So if you wanted to run these compilations on your on a server, you could. Why would you want to do that? Well, maybe you want to build for iOS, but you only have a Windows machine. So anyways, I was alert debugging over here, and you'll notice I popped up an alert, but there's a problem. These native alerts are going to talk about where they're coming from. And in this particular case, this native alert is going to say, I just came from index.html, which is hella uncool in the App Store. So what I really want here is to get a native alert. And you can do that. So we call them dialogues inside of Cordova. It's like, yeah, Cordova Dialogs. And so there's this Cordova Dialogues plugin. I'm just going to grab this little bit of code here. So this is going to let me install this plugin into this platform. It's going to grab it. It's going to install it for Android and iOS because those are the platforms I care about. I'm going to jump in here. I'm going to edit my www folder again. And so Cordova Dialogues are a little different. We hang off of navigator.notification. And we give a slightly better API where we can have message, an alert callback, a title, and a button name. So I'm just going to steal that little snippet. I'm really just doing this for the sake of demonstration purposes that you can access native bits. I'm going to show you the source code of this plugin in a second. So hi. I'm not going to pass a callback on the after event. I'm going to change the title to something like my test app. And I'm going to change the name of the button to Peace Out, Yo. Just because. Phonegap run iOS. Oh, let's kill the simulator so that we're not. I might have been. Oh, no. Good. OK, so that was the first alert. Oh, no. It didn't work. What happened? Whoop. What did I call it? My test app?
Did you install that plugin? Or you did?
Yeah, it's there. Navigator.notification holder. Oh, you know why?
The alert?
No. I didn't put it in on device ready.
Oh, right.
Add event listener. So this is another gotcha, and it's funny that it still gets me today. Phonegap creates a native bridge between the back of the code and the web view. In order for us to communicate between the two, I have to wait for the device to be ready. So this function was executing before the device was actually ready to execute that function, if that makes any sense at all.
Yeah, so the way Phonegap works is that it gives you this chromeless web view, right? But we're passing these messages through to the native layer, and then these plugins, which are written in native code, like to invoke a camera or to do get the accelerometer data. It just gets passed through and passed back. So the device ready helps you mount and know when you can ready to talk to the native layer.
Oh, super weird. Demo fail, Brian. Add event list. Did I spell listener right?
This is why I love live coding.
Yeah, 'cause
It's like unpredictable.
Oh, yeah.
Outside HTML, can you get
No, you know what it is, man? I forgot to include Cordova JS. That's what it was. Okay, so the other bit, so add event listener is one bit that you have to do. The other bit is you have to include Cordova JS or Phonegap JS. Either will work. They're kind of interchangeable. And this is HTML5, so you don't need to quote attributes anymore. So that was totally correct.
Although Google's been doing that for years to save
Kilobytes.
Kilobytes.
Maybe that's why that landed in the spec.
Huh. Yeah.
I don't know. All right, this time it will work. I promise you.
Oh yeah.
Yay.
Nice.
So this dialogue's native, and to prove that, let's show you how beautiful native dialogues look on Android. That's funny that we just went through all the common mistakes. Oh, photo booth of Phonegap in one go.
So something to note about doing Android development is you'll notice he's using the simulator for iOS, but he's going right to the device for Android. Android has simulators, but they're really slow, and building to the device is actually really fast and obviously more realistic, right? So you'll see that's quite common. So if you're getting started with Phonegap, I'd encourage you to just avoid the Android simulator altogether if you have an Android device. Just
there is
go
a
right
new
to
one,
the device.
but it's pay for use called Genymotion,
Oh yeah.
which a lot of people are using now. Yeah. So there is one that's good now, basically. Plugin dialog. Did I spell that right?
Yeah.
I think I did.
Yep.
Nope. I did not. So all of Cordova's codes that can be found at Apache, and there's kind of a lot of it. Turns out this whole Phonegap thing was a lot more work than we bargained for. Cordova plugin Dialogues. So this is an example of a canonical plugin. There's hundreds of these things out there for every functionality that your device could possibly have. And if you look at it, a plugin actually looks a lot like a Phonegap app. It has a www folder, and inside of that, there'll be a little bit of JavaScript. And that little tiny bit of JavaScript will expose an interface that you use. So in our case, we used the one that said alert, which is right here. So this is the thing that we called, but it under the hood called something called exec. And exec did the right thing by calling the native code we wanted. And so in the case of that, you go into source. So in the case of iOS, we had CDV notification got called. And this would have called this alert on iOS. In the case of Android, so Phonegap is a very brute force solution. We re-implement everything on every platform with the same interface, and then we test the hell out of it. So in this case, we've got an Android equivalent set of code that runs natively. Point of the story here is that there's nothing hidden from you. If you want to access a native feature, you can. And most likely, if you want to have access to those native features, we've already written it for you. So everything that the native platform has available to it, you can use. And you can embed Phonegap in a native app and have native UI if you want, if you have native programmers. That's the key learning there. Did you have a question, dude?
Yeah, can you explain one more time what does app.phonegap do? That little service you pulled up there?
Oh, this guy, yeah. So app.phonegap.com is a developer app. So I'll show you what it does. Maybe, if this works. So my test app, I can do Phonegap serve here. And this will start a little web server on this address of my app. In this case, I'm going to get these dialogues because, please don't do this anymore, because this isn't a Phonegap app. you can see it loaded in the browser. The Phonegap app, I'll launch this one, but I can't load it because I'm tethering, and I think that would create a vortex in space-time. Photo booth. So this is the Phonegap app right there.
So you can download this app from the App Store, and then that saves you like the work of having to get all of the provisioning working. So this will talk over your local network and run the www directory in a Phonegap environment.
So you would enter the URL from here into there, and it would load on this phone.
So it's like, it's all the native parts that
Com-
would normally be built with
Yeah.
Phonegap app already built for you.
So you don't have to do any compiling.
Just point the web.
So you'll still have to if you want to get App Store distribution at the end, but this moves that to that end step. We're sort of showing you all the bits at once. Yeah. And actually, we're way over time already. I'm just noticing. So if you guys have more questions, Brock and I are going to be hanging out all day.
Yep. Thanks for coming.
Thank you.